Good morning to all. Now the session on problems on Fourier transformations is going on. Let us start. Now, before going for some other problems, there are two important formulae. These two formulas are very important. Integral 0 to infinity e power minus ax cos bx dx, or you can make it other one. Okay. After that, after properties we will discuss. Next topic is properties. The next topic is properties of Fourier transforms. Properties of Fourier transforms. Now just look at Fourier transforms. Now just we are discussing its properties. Now the first property is called change of scale property. Second one is called shifting property. Third property is modulation theorem. Very important concept. This is the modulation theorem or modulation property. So these three properties now we are going to discuss on Fourier transforms. Okay, scaling, shifting, modulation theorem. Now just look at them. The first one is called scaling property. What does the scaling property says? If the Fourier transformation of a signal f of t is equal to f of s, if it is true, then Fourier transformation of f of at, because scaling, so a multiplier with the variable t, that is equal to, in the previous case only f of s, that is equal to 1 by a f of s. I will explain again. And Fourier transformation of f of t by a, that is equal to a times f of as. Now just look at the first one is called scaling property. If Fourier transformation of any signal is f of s, that means what? T domain is changed into s domain. Then the scaling can be in two ways. Here a is multiplied, then a will be dividing in the s domain. If a is divided in the t domain, it will be multiplying in the s domain. Here it is divided, there it should be multiplied. If here it is multiplied, there it should be divided. That is called scaling property. Students have to remember this. Multiplication, right side, division. If it were division, right side, multiplication. First property, scaling property. Second one is called shifting property. Here one important point. We already discussed the concept of shifting property. In signals, there are two shifting. Right hand shifting, left hand LHS shifting. Right hand side shifting always makes delay. Left hand side shifting always makes advancement of the signal. So only two properties in shifting. One is delay, another one is advancing. If a signal advances, no problem arises. But the problem will be arising when any given signal is delayed by a small quantity of seconds. Therefore, whenever we are using the concept of shifting, students have to remember that here shifting means we are going to focus only on the delaying signal but not on advancing signal. That's why shifting means always taking the delaying signal. Not only for transformations, everywhere this is same. Now, shifting means what? Same concept. If the Fourier transformation of any given signal f of t equal to f of s, now then the Fourier transformation of a signal, if it were delayed by a seconds, look at a seconds, then it will become e power minus jsa into f of s. This is minus JSA into f of s. This is shifting property, very important property, shifting property. So now scaling property, shifting property. Understanding? So we always consider right hand signal, that means delayed signal. We consider always only delayed signal. No need to consider advancing signal, no need to consider. Here delayed signal only you have to make it. So out of three properties, first property is scaling, second property is shifting. Now we are discussing these three properties on Fourier transforms. Now the third and the very important concept is called modulation property or modulation theorem of Fourier transforms. Now just look at the third one, very important concept, that is called what? Modulation property or modulation theorem. You can also call it as a theorem, modulation property or modulation theorem. Directly they are asking write the modulation theorem or property of Fourier transforms like that. So just look at, if the Fourier transformation of any given signal f of t is equal to f of s, then the Fourier transformation of the given signal, if it were multiplied by a cosine signal, then its value will be half into f of s minus a plus f of s plus a. Look at, very important concept. This now we have to prove it. The statement, a modulation statement, if the Fourier transformation of a signal f of t equal to f of s, then any signal, if it were multiplied by a cosine signal, then the output will be like that. That is called the modulation property or modulation theorem of the Fourier transforms. Now let us make it. The Fourier transformation of cos at with respect to f of t, that is equal to the Fourier transformation of f of t into what is cos at? Cos at can be written as e power j a t plus e power minus j a t by 2 by using Euler's formula. It can be written as e power j a. Now it can be written as e power j a t plus minus of e power minus j a t by 2. Now half is constant, therefore half equal to f of e power j a t into f of t plus e power minus j a t into f of t. You can make it like this. Understanding? Now this is equivalent to half of Fourier transformation of e power j a t into f of t plus Fourier transformation of e power minus j a t into f of t. Now you can make it like this. Now this is equivalent to half into what is the shifting theorem? This will become f of s minus a plus this will become f of s plus a. F of s plus a. Understanding shifting theorem. So this is equal to half of f of s minus a plus f of s plus a. This is the modulation theorem. Understanding? This is the modulation theorem. Very important concept. Understanding? So now what does a modulation theorem say? A modulation theorem says that if Fourier transformation of any given signal that is equal to f of s, if the signal multiplied by a cosine signal multiplied by a cosine signal, then the signal will be split into two parts. That is equal to half of, look at f of s. This f of s will become one side f of s minus a, on the other side f of s plus a. This is called modulation. This concept is called modulation. Now, already we discussed on this one, we discussed, the modulation and demodulation concepts by using the device on modem in computers and laptops, etc. Modem. Modulation concept and the demodulation concept. Combining these two, we are going to use in modem. So this is a very important concept of modulation property of Fourier transforms. Very easy. Students have to just split the value of cos 80 into like this. Because how you get in intermediate is done on Euler's formula, e power j 80. Value how much? Cos 80 plus j sin 80. E power minus j 80. How much? Cos 80 minus j sin 80. If you add these two, it will become e power j 80 plus e power minus j 80. That is equal to, cancelling these two, you will get 2 cos 80. Therefore, cos 80, that is equal to e power j 80 plus e power minus j 80 by 2. Understanding? Only that concept students have to remember. The remaining everything, multiplying with this one, taking half constant out of the function, you will get the entire signal is split into summation of two signals. Now Fourier transformation of this signal, Fourier transformation of that signal. This is called the frequency shifting property. By using which property? This is called frequency shifting property. By using frequency shifting property. Frequency shifting property. So these three are very important for students on Fourier transforms. So just I am making you recollecting this one. Now just look at Fourier transformations. What we are discussing about properties. Properties means as first scaling. First one is called scaling property. Second one is called shifting property. The third one is called modulation property. Out of this one, this is very important needed, modulation property on Fourier transforms. So now we discussed all the possible properties on Fourier transforms. This question was repeated 2-3 times in examinations. Okay, we will be getting next one. Thank you.